C1V1 equals C2V2, as well as molecular weight conversions. These are all really great, and it's really important to know how to do them by hand. But once you know how to actually do them, then you can tell a spreadsheet to do it for you. So here is an example spreadsheet of the kinds of calculations that I have spreadsheets do for me all the time. And so it goes over preparing stocks, doing dilutions, making master mixes, dealing with protein concentration conversions. I also have a page with graphics and a page with links to various things, including an experimental spreadsheet where I go more into detail of setting up an actual experiment. There are also some cheat sheets for some of these conversions for when you're doing it by hand and things, and tips for using spreadsheets. But here's just an example. So over here, I have the stock concentrations for in this case, I only have the ones that I'm dealing with in this example. Sometimes I'll have a longer list just so I can have a handy go-to if I want to mix and match different components or make different components. I have the same sort of base spreadsheet I can use. That's kind of like my inventory. And this can be things that I have or things that I want to have. And then the molecular or formula weight. And so that's going to tell you grams per mole. Technically, a formula weight can be used for pretty much anything, whereas a molecular weight can't be used for things that aren't just covalent compounds. And so if you say have a sugar, well, that would the molecular weight and the formula weight would be the same. But if you have a salt, well, then it dissociates when you dissolve it. And so technically, you wouldn't have a molecular weight, you would have a formula weight. But you'll typically see formula weight or molecular weight used interchangeably, abbreviated FW or MW on the bottle, and that's just going to tell you the grams per mole. It's really, really important that you look at the bottle and see the actual listed molecular weight or formula weight for the thing you're using. Because if, say, you have a disodium salt, the sodiums are going to add to the formula weight, and so this is going to be a larger value than if you just had free NADH. Additionally, sometimes you'll have hydrates, so they'll have water hanging out with them, and you might have like a hexahydrate, which would have 6 waters, versus trihydrate, which would have 3 waters, and so those would have different formula weights. And so it's important that you look and see what's on your. So often you're gonna have to be figuring out how much of a solid to weigh out in order to make a liquid with a desired molarity. Often we're working in millimolar, and so I have a lot of these things set to be in millimolar. If you want to convert to a different unit, then you just have to go ahead and use unit conversions, multiply, divide by 1,000, that sort of thing. And so again, here it's really why it's so important to actually know what's going on behind the scenes, but then to be able to get the computer to do the hard for you. So when you want to figure out how much mass you're going to need, you're going to multiply the molecular weight, or remember you might see it listed as formula weight, times the molarity that you want, times the volume that you want, and that'll give you the mass. And so you can just have a spreadsheet that for you. And note that here I have the divided by 1,000 to account for the fact that it's in millimolar. And so take that away if you want it to be in molar, and then change it if you want it to be a different big bag. And so here you can either have it directed to the things that you have on the side over here. So if you use these a lot, you use the same concentrations, you can put these over here and then direct it to there, or you can just enter them directly in the cells here. And so this will then calculate how much mass you'll need. You'll then dissolve that in a liquid and adjust it to the volume. When you're dealing with smaller quantities of solids, sometimes what's easier is to actually, instead of trying to weigh out a very precise, exact, but tiny amount, what you can do is you can just calculate how much volume you need and for the mass that you do weigh out. And so this is going to do that calculation for you. And so here it'll calculate how much you are going to need of it, similarly to how we did it before, except here it's going to be converting things to makes per mil, calculate the desired makes per mil. It will then calculate the needed mass, and it'll do that. Also, it will tell you the needed mass in grams because that's typically how you see it written out on your scale and your balance when you're weighing things out. And so it's convenient just to see what it's going to look like too. If you then go and you make that precise exact mass, then that's great, and you can go exactly to your desired volume. But if you measure a slightly different mass, well, then you have a slightly different volume. And so here in this example, if I wanted 10 milliliters of 10 molar of this,
I would need 70.9 milligrams. But say I measured out 73 mils. In this case, I would need a little more than 10 mils because I weighed out a little more than 70.9 milligrams. So this will calculate that I need 10.29 mils. And here it's just again with a different solid. And note that I have a spot where I can put the solvent because these will have different solvents in some cases. And then it'll calculate the amount that I will actually need. And so that's going to be in green. In blue are things I needed to change. The formula weights here, that's where I was directing it over here. We could also put it in directly here. And then these ones that aren't color coded are auto calculating green. Now, sometimes what happens is that you realize after the fact that you had the wrong formula weight, or you had a slightly different volume than you meant, or maybe you realize you forgot to subtract something or you dropped, I don't know, whatever. There's some sort of change, and now you're a MIGS and you know the MIGS, you know the mils, but you don't know the molarity. And so this will go ahead and calculate that for you. And so the divided by thousands are taking into account that I have the things in like milligrams and milliliters. And so this will go and calculate that for you. So that's useful. And it's similar to the calculations that I have on my protein preparation and protein calculation molecular weight conversion sheets. So this is how you would make the solutions from solids. You can also make just dilutions of solutions that you already had.
For dilution calculations here, it is just simple C1V1 equals C2V2. And so here I have it set to do it in milliliters as well as microliters. And again, you can just change these things to meet whatever your needs are. And so if you have your C1, your V2, and your C2, you can calculate your V1, so that volume that you need. There's also master mixes, and so here it's set to do things by reaction, per reaction, like how much you need per reaction. And so here you can either set these individually, you can actually just come and put the values in, or you can have it calculate based on the C1V1 equals C2V2 calculations. Here, if you can make a master mix, so say some of those components, you can actually, they're the same with all your reactions, and so you can pre-mix them together. This is going to say, okay, if I want to premix my NADH and my buffer, this is going to tell me how much I will need per reaction of the master mix. And so it's going to sum up those two components per reaction. I then tell it how many reactions I want, and it'll calculate the volume that I'll need. Now what I want it to do is I want to tell it, okay, well, that's how much I'll need, but I'll actually want to make extra because I want to have enough for additional runs. And so how much extra you want to make depends on the experiment, how much things cost, and convenience. So it's easy to make things like 10 mils or 5 mils, but it's harder to make things like 2.587 mils or something like that. This is going to then calculate how much of each of the components you need. And so for your master mix, you're going to have 980 microliters of master mix per reaction, to which you'd add 10 of the enzyme and 10 of the oxaloacetate. So the things that aren't shared between them all. The amount that you're going to need of the NADH in the buffer is going to be the total amount you're preparing, 10 mils, times the fractional volume of the component. So in this case, we say, okay, well, how much volume was the NADH of the master mix? And so it was 10 microliters per reaction out of 980 microliters of master mix per reaction. And so then that's going to be 10 times that fraction. And the same idea with the buffer. Note that for some of these, I put dollar signs, and dollar signs are going to make it so that you can use absolute references, and so that it's directing a cell to always go back to that cell, or at least always go back to that column or that row. And so be careful when you use these, because sometimes it can direct to cells that you don't actually want it to when you're copying things, or it won't direct to the new cells. So just be careful and go through and make sure it's actually directing to the cells that you want when you go and make things. For protein concentrations, here working with protein concentrations, you're often working with kilodaltons, and so this is going to calculate molarity from mgs per mil from molarity. Here's what's going on under the hood. This is in kilodaltons, so if you want to convert, you want things to be in daltons, or you want things to not be in micromolar, because I typically use micromolar with my proteins, but you can go ahead and change that as needed. And typically too, I make a little like guide to what my protein preps are. Couple other quick notes. One is that you might need to decrease the number of decimal places shown, and so it's often convenient to only show how many digits you can get on your balance or something like that. And you can do that easily over here, similar buttons in Excel. Another thing is drag down from the right-hand corner to copy the formula down. You can do all sorts of cool things, and so you just need to play around. And you can do a lot of spreadsheets, but you can actually do a lot more with computer programming. And so Python is really great. I recommend scientists learn it, and you can make some formulas and programs to actually do some of these calculations for you. But when you're working with people who don't know coding, or if you're a little rusty on your coding, or you don't know coding, spreadsheets can be a really great way to go in order to calculate things for you. But remember that you need to actually know the math behind what's going on in order to tell a spreadsheet how to do it for you. And make sure that you're always directing to the cells that you think you are, and that you're doing a reasonableness check to make sure that the values that it's calculating are values that are reasonable. And so if you're doing a dilution calculation, one, your answer should never be negative, and two, your answer should be your final concentration, say, should be lower than your initial concentration, and your final volume should be higher than your initial volume. And so you just want to kind of sanity check those things, make sure that the values are reasonable. And if they're not, go and look and see what you might be doing wrong. Note too that once you calculate a value, if you go and paste it in another cell, you're going to get errors and stuff. You want to instead do Command Shift V if all you want to paste is the value. So Command Shift V. And so here you can see it didn't even paste the format of the background. If I want to copy the format of the background, what I can do is if I come over here and I do the little paint format, it'll then format this. And it'll also do if it changed the text font or the size, bold, that sort of thing. That'll all copy there. And so, but again, Command Shift V if you just want the values. And you can also go to like Edit, Paste Special and see some of the options there. But Command Shift V will just do the values. And typically what I'll have is I'll have like a to prepare tab for my experiments. So if you look at the experimental spreadsheet, you'll see it. And there is where I copy the values, just the values into there to have like a go-to guide of, okay, this is what I need to do without having to see all the calculations. And again, here's just the graphics and the links, and hope this was helpful.